Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will learn the core concepts of landslides, which is one of the geohazards, its causes, mitigation and prevention in the view of civil engineering applications. So, what is meant by landslide? So causes, effects, prevention and case studies in the structural geology are monitored for the sake of prevention and mitigation techniques. The physics behind that is the slope is not a static hill. It is a battleground between opposing forces. That forces are shear stress or shear strength. So shear stress is a driving force versus shear strength is a resisting force. So at the same time, both the forces are in action where the balance tips, the earth restores equilibrium through failure. Means the physics of equilibrium is a natural hillside or engineered slope is treated not a static feature but as a dynamic boundary. It represents a continuous mechanical battleground between opposing geotechnical forces. So what is meant by driving and resisting forces? The hazard is dictated by the balance of shear stress, where the gravitational driving force pulling material downward, and the shear strength, where the resisting force holding it back. Means when the natural or artificial balance tips, the slope can no longer support its own mass. Due to that slope, the earth abruptly restores its mechanical equilibrium through structural slope failure, creating a landslide. Here, the gravity sliding, which is the energy restoration, or we can say that restoring equilibrium. The two parts, uplifted block and trough. Secondly, gravity slide and gap closure. So these two components or these two images shows the actual sliding occurred with reference to the tectonic plates due to the forces. That forces are due to the vibrations. So the geohazard evaluation requires distinguishing between deep seated mountain building forces from superficial gravity driven adjustments, or we can say that surface activity. So the landslides are physically defined as the earth's special mechanism for rapidly resolving accumulated potential energy into sudden kinetic movement. The upper portion of a structurally uplifted geologic block, or we can say the surface, which becomes mechanically unstable along a fault line due to the fracture. The gravity forces the mass to slide downward, closing gaps and filling adjacent topographic throats, so that the overall existing structure may get settled in downward direction or may get uplifted in the upward direction. Due to that, existing surface will get disturbed with reference to that fault line or fault plane. Classification by the movement geometry, which is dependent on the geometric classification of three parts: rotation of the forces, translation of the forces, chaos or falls due to the forces. So first, rotation, which is a displacement along a curved surface, which is internal rotation of the mass. Second, translation, which is a displacement along a uniform plane or within the plane where no internal rotation is occurred. And third, chaos, or we can say the falls, where the rapid disintegration into dissolved breccia, or we can say that rock fragments, that is chaos. A rotational hazard, static geological lines on opposite sides of a slip fault are no longer parallel after a failure event occurs. The movement behaves, the rotational movement behaves around a distinct center of rotation situated within the fault plane. This creates a concave scoop-like break within the hillside. The field identification relies on tracking a series of step-like blocks that visibly tilt backward into a slope phase in the rotation phase. In translational phase, unlike rotational failures, the geological strata on opposite sides of a translational slip surface remain parallel to each other. The unstable mass translates linearly downward along an existing plane of weakness such as bedding plane or joint fracture. The high geohazard zones occur in the sheet structures where underlying rock layers run perfectly parallel to the exposed angle of the slope face. In the third, where Chow's theory, or we can say that the fragmentation of the rocks, which represents a catastrophic stage of slope failure, where the internal arrangement of moving blocks becomes entirely confused and distorted. High vertical cliffs faces with dense intersection or dense intersecting joints network are prone to sudden failure or explosion of the rock due to the gravitational forces. Here, inherent instability, most important concept, where the structure and lithology in the picture. So structure and lithological characteristics shows the stability and instability concept. Here, deep versus slope angles. Deep versus slope angles. Now, slope is a physically prime when the internal dip angle of the underlying geological bedding planes exceeds the material's natural angle of friction. So catastrophic is a prime when the dip of the bedding planes exceed the angle of friction. Secondly, hillside creep. Hillside creep refers to the slow interceptable bedding of rocks, or we can say movement of rock strata downslope prior to a major failure event, which creep can distort surface data and mask deeper structural instability. Third, jointing planes of weakness gives the natural joints create systematic planes of structural weakness perpendicular to regional fold axis, essentially slicing solid rock into individual movable blocks. So, at the initial level and at the end level, initial level the rocks are all stable with reference to the stability, structure, and lithology. After earthquake, after landslide, there will be a tremendous change in between the lithological characteristics and due to that structure also. Now, structural displacement and disruption. Field mapping of active faults relies on observing offset stream ridges, disrupted vegetation bands, and broken river profiles. So surface geomorphic clues are dependent these 3 points. So infrastructure discontinuity, which is a linear civil infrastructure elements such as road, pipelines, rail tracks are disturbed or displaced with reference to that geohazard. The net slip determinations, where engineers must calculate the true net slip, the total vector distance measured across the subterranean fault, where surface between two formerly adjacent geological points monitored. The zonation mapping, where we have to identify the weaknesses. So here the picture shows that the existing contours with reference to the available fault, or we can say that the structures of the rock inside the earth. So fault scrap, landslide scrap, fault scrap, then linements. These are the sections where T joints are there or some lines or dotted lines are there. So these are the actual crack planes, or we can say that the fault plane. With reference to that, we have to mark the zonation, or we have to mark the weaker rock fractures planes. So fault and landslide scraps are the topographic hazard map, track steep linear slopes indicating recent movement, where engineers must distinguish deep-seated fault from shallow superficial landslide scraps. Secondly, triangular facets. So triangular facets, these are the truncated triangular mountain faces, indicate that an active landslide which has cleanly sheared off the front of the mountain spur. And third, lineament fractures, where linear fractures map from satellites reveal regional bedrock, fracture system, and hidden zones of tectonic weakness. So these three scraps, triangular facets, and lineaments are the weaker zone we have to identify, and we have to plan the zonation mapping accordingly. With reference to that, we have to check the foundation, or we have to take the decision for the site selection criteria for each and every structure. Here we have to prevent the hazard, so that restoring mechanical equilibrium is most important concept, where stable and unstable activities are there. What is the strategy behind that? The increase the coefficient of friction or reduce the driving angle. So drainage, where lowers fluid pressure, allowing the rock's natural friction to re-engage. Now, what is meant by the geometric grading? Reducing the slope angle to below the critical 26.5 degree threshold. Means if we have to maintain the lithology or the topography stable, so we have to maintain the 26.5 degree threshold angle, so that the geometric grading will be stable. With reference to that, the drainage, where lower fluid pressure will be managed, allowing the rock natural friction to re-engage. Otherwise, it will be unstable. So that the geotechnical prevention relies on artificially increasing a slope's coefficient of friction or geometrically reducing its driving angle. The installing horizontal drainage pipes lowers internal pore fluid pressure. This allows the rock mass natural friction to re-engage and stabilize the slope. So these are all the pipes where orange color lines are there, and they collect the all water seepage drop by drop, so that we can prevent or we can make the stability, which involves mechanically cutting traces or regrading a hillside to drop its slope angle safely below the critical stability thresholds. So these are all the preventive measures where we have to restore the mechanism equilibrium on the lithological characteristics, or we can say that topographical features. Technique. One of the most important point, slope stabilization technique. Slope are the natural phenomenon, so we have to stabilize that slope by the shotcreting methodology or by the rock bolting, where retaining walls are constructed to prevent the landslides. So retaining, building the external resistance to counteract the movement or the component of gravity W sin theta. We can also say that heavy external retaining structures are constructed at the toe of slope to supply artificial resistance against gravitational driving force. So the high tensile steel rock bolts are driven deep past or deep inside the internal safety plane into stable bedrock, just like rock bolts. This is a combined with a surface layer of sprayed concrete, just like the shotcreting process, to lock loose breccia together, or we can say that rock tectonic plates together. Planting deep rooting vegetation binds superficial soils, or just like the vegetation, we have to provide the tree plantation activity, so that roots of the trees make engage the whole tectonic plates with reference to that rock bolting activity. One of the case study is that gravity in action, that is the Himalayan context. With reference to that Himalayan context, the thrust sheet mechanism is there. Massive mountain failures in active orogenic zones like the Himalayan ranges, as the regional thrust sheets are there, or we can say that the tectonic plates are there. They are behaving like the thrust sheet, which moving across low angle detachment faults. High intensity monsoon rainfall can raise pore water pressure. This completely disturbs deep slope equilibrium, causing massive sheets of the earth to travel miles over low friction plains. These combined structural and climatic geohazard present extreme risk to the communities, societies, hydropower dams, power plants, and transportation corridors too. Stay tuned, guys. Happy learning.